Circuit mapping is a process of moving from a breadboard to the finished circuit board. We're going to do this process using circuit map. So this is just a drawing of what your circuit will look like when it's done, and you just have to decide where certain parts go. So the handout you get has a front and a back, and they're actually photocopied to be back to back so that you can put them on a light table, and if you want to put lights on the back as well as the front, that's possible. I'm going to focus on just the front in this video. So first of all, what's happening in this diagram? So at the top we just have a soldering demo. Here's your microcontroller and what the pins are. Here is the actual circuit board, a large version of it, and some items are already placed so you don't have to worry about them. So your microcontroller is going to go in the center no matter what. You're going to have your little USB breakout down here no matter what. You're going to have your programming header over here no matter what. 0.1 UF capacitor, a 10K resistor, a 10 UF capacitor. You've got your switch over here. You've got a connection from the microcontroller to power, and you've got a connection from the microcontroller to ground, and you've got your crystal. So actually a large portion of your circuit is already pre-mapped. What we need to decide is where are we going to put our LEDs and our resistors, where are we going to hook up our RGB LED setup, and we need to add in a little test LED as well. So start with the test LED. So for all of the example programming that we're doing, we need the test LED hooked to D13. So what we're going to do is we're just going to go ahead and draw that. Now I could draw a schematic symbol, or I could just do the LED, but I want to indicate what the positive and negative leg is. So I want the negative leg going to ground, and I want the positive going to digital 13 on the microcontroller. Alright, next up I want to do, well, let's do the RGB LED. So the RGB LED is going to be hooked to digital pin 6. Again, you could use a different pin, but for all the examples you're using digital 6. So I need to take that RGB LED resistor to an empty row. So here's my resistor. I'm going to take it to this empty row here. And what I mean by empty row is that each of these rows is electronically connected. So we have positive row, positive row, positive row, positive row, positive row. So these vertical rows of positive, we have actually 5 of them. And then we have 5 vertical rows of negative. So this is connected to this negative, to this negative, to this negative, to this negative. So all the positives and negatives are connected. And then horizontally, we have things that connect together in sets of 5. With the exception of down here near the microcontroller, we have sets of 2. So I've hooked my resistor from D6 to an empty row of 2 over here, and then I've got to hook it to the RGB LED. So I'm going to draw my RGB LED strip up here, and there's 5 of them, so I'm just going to indicate that. And there's 3 connections to the RGB LED. So I'm going to make one here, and then one of those connections has to go to negative, and one of those connections should go down to here to VCC of the microcontroller. So the RGBs can be broken up, you can put them wherever you want, but they have 3 wires to connect, and one is a data line that goes to the microcontroller. One is ground for the RGB LEDs, and one is a 5-volt connection for the RGB LEDs, and we're going to hook that directly to the microcontroller. So that's my RGB setup. Now I got my white LEDs here, and there are 8 total, so I have to decide where to put them. Now they can go wherever you want, but here's the rule. One leg has to go to negative, and the other leg has to go to a resistor to positive. So for example, there's a third rule actually. You cannot put both legs on the same horizontal row. So I could put one here, and I'm going to draw it as a square because as you might see here, these are little square sockets that the LEDs are going to go into. So there I draw my LED. I got my negative leg and my positive leg. So the negative leg I put directly into negative, and the positive leg I've got to get to positive somehow. So this is a positive row, this is a positive row. So what I'm going to do is draw my little resistor, and I'm just going to go over to this positive row. And I'm just indicating that that's a resistor. So that works. Now, if I moved that LED over one, I'm going to do this in pencil so I can erase it. But if I were to put that LED here, that's a no-go. Because I actually have put both legs of the LED on the same row and they're connected electronically, and that's no good. Alright. What I could do is this. I could put my LED this direction. There's my positive leg and my negative leg, and I could hook the negative leg over to negative with a wire, and then have the positive go over to positive, and that would work just fine. So there's two LEDs. I've got to put 8 all together. So I can really put them wherever I want. Again, as long as they can't fall in the same row. So I can't put another LED on the same row. But I can put them wherever I want as long as they're not horizontally in the same row and they don't fall in a row with something else. So I could put an LED here, and I could have wire to negative and resistor to positive. I like to label the positive and negative leg. I could put one over here and have, there's my negative, there's my positive, and have a resistor going over here to positive. I could put one right down here, and there's my positive and my negative, so I hook my negative leg over to some negative and my positive leg to the positive row. So I got 1, 2, 3, 4, 5. I need 3 more. I could have one down here. So you might be asking, like, well, who cares where they're at? Well, it just matters how you want them to look in your lamp. If you want it really concentrated in one area, then you want to put your LEDs really close together. If you want it spread out, then you want to spread your LEDs out. You can extend the LEDs off the board, and if you choose to do that, I would indicate that here, maybe by drawing that the socket is off the board. And then this one still has to hook to a resistor, which I would put down here on the board, but the LED itself is extended off the board. So what we want to do, so we got to put a couple more here. So maybe I'll have another one extended off the board up here. One leg going to negative. And then the other one would go to a resistor to positive. Now I'm doing this in pen, black pen, just so you can see it, but I would recommend doing it in pencil so you can erase things when you make mistakes. This is just a planning tool, just so we know where things are going to be. There's my negative, there's my positive. Okay, so I got 1, 2, 3, 4, 5, 6, 7, 8. There's my 8 LEDs. Oh wait, do I have 9 here? I actually have 9. Well, you gotta do 8. Alright, so hopefully that helps. Good luck.